Every year, dozens of asteroids approach Earth at distances closer than the Moon, yet catastrophic collisions are extremely rare. Now, a new study proposes that our planet has a built-in defense system, the intense gravitational force of Earth, which it utilizes to eliminate intruding asteroids. The massive masses of planets and their moons mean they exert enormous gravitational forces on nearby objects. The gravitational differences these objects experience, known as tidal forces, astronomers use them to explain how the Moon causes tides on Earth, can be so powerful in some cases that objects break apart, a process called tidal disruption. In 1994, space enthusiasts witnessed the impressive power of tidal disruption when pieces of comet Shoemaker-Levy 9, torn apart by Jupiter's tidal forces during a close encounter 2 years earlier, crashed into the gas giant. However, for decades, astronomers could not find evidence that Earth and other terrestrial planets tidally disrupt passing asteroids or comets. Earth's intense gravity could shield us from asteroids. Mikael Granvik, the lead author of the new study and a planetologist at Luleå University of Technology in Sweden, had long been searching for these Earth-approaching asteroids that had undergone gravitational disruption, NEAs. About 10 years ago, I was looking for families of NEAs that would have formed in such tidal disruptions, but I didn't find any, Granvik told Live Science. A subsequent study explained why. Any fragments formed in this way would mix in with the background so quickly that identifying a specific family was impossible, he said. The search for tidally disrupted asteroids remained at a standstill until Granvik had a brilliant idea. In 2016, he contributed to creating a model that calculated the trajectories of asteroids of various sizes to determine their numbers at different distances from the Sun. Granvik and his colleagues compared their model's results with 7 years of asteroid observations collected by the Catalina Sky Survey, a NASA-funded program based on a telescope in Arizona that detects NEAs. But their estimates massively underestimated the number of certain asteroids, those observed at distances where Earth and Venus orbit the Sun. Most of these lost asteroids were quite small, meandering about on nearly circular paths around the Sun, more or less in the same plane as the orbits of Earth and Venus. Then came Granvik's moment of brilliance. He realized that these unusual asteroids could be fragments tidally disrupted from larger asteroids. Gravity could pose problems but is not a cause for panic. To test this idea, Granvik and co-author Kevin Walsh, a researcher at the Southwest Research Institute in the USA, considered a scenario where asteroids encountering rocky planets lose between 50% and 90% of their mass, generating streams of fragments. Their model accurately accounted for previously inexplicable asteroids, suggesting they were created by tidal disruptions. They described their findings in a new study, accepted for publication in the Astrophysical Journal Letters and available in the archive preprint database. While individual families are hard to find, the combination of several families will produce a signature that we can identify, Granvik said. Additional simulations showed that such fragments lingered around for a long time, with an average duration of 9 million years before colliding with the Sun or a planet or being ejected from the solar system. Earth's intense gravity may help deflect asteroids, but it also creates issues, generating more NEAs with chances of impacting our planet. However, don't panic, as these fragments are smaller than 1 kilometer in diameter and do not pose an extinction-level threat, Granvik said. Nevertheless, they increase the possibilities of Tunguska and Chelyabinsk-level events, the two largest asteroid impact events in recent history.